Sir, can we start the session?
Yes, please. We're ready.
Sahu, sir? Sahu, sir, can we go ahead? I think I just left. Samarji, we can start, right?
Yes, madam. Yes.
So, very good morning and very warm welcome to Shri Ashish P. Kovilkar, sir, Senior Director, HPC Technologies at the Center for Development of Advanced Computing, Pune. Dr. Narottam Sahu, sir, Advisor GUJCOST. Shri Samrit Maiti, Joint Director, HPC Technologies at CDAC. Speakers from CDAC, Dr. Poonam Bhargav, Principal Scientific Officer GUJCOST, my GUJCOST colleagues, faculties, research scholars, and students who have joined us in this session from various institutes. I welcome you all to the training program on high performance computing and deep learning. It's almost a year when we had a similar training session last year on virtual mode. The situation is more or less same today, but that doesn't stop us from looking forward. So we are here today to dive more deeper into HPC and deep learning techniques. So I request Sahu sir to give the welcome remarks for this 4-day long training session. Sir.
Yes, good morning to everybody. Respected our guest of honor, Sri Ashish Kovilkar sir, Senior Director HPC CDAC Pune, Sri Samrit Maiti ji, Joint Director CDAC, all our faculties from the CDAC, all our professors, associate professors, assistant professors, and research scholars at our 26 supercomputer facilities institutions, all the other faculties and students from other institutions in Gujarat and outside Gujarat. So welcome to this virtual training program, 4-day training program on supercomputing, computer HPC and deep learning. On behalf of Gujarat Council on Science and Technology, GUJCOST, Department of Science and Technology, Government of Gujarat, we welcome our chief guest, Sri Ashish Kubelkar sir, all the faculties from the Pune, CDAC Pune, and all our participating faculties from different engineering and science research institutions all across the country. So it's a almost 1.5 years, and last year also by this September we have another training programs with the kind support and cooperations of CDAC Pune. So again we came across this pandemic situation in a very stringent way, stronger way. So again we are out of our university, college, institutions, departments, and we are working in this virtual platform, virtual method. But still we learned a lot in this process, and we understand that how much the technology has the role and a significance in tackling these types of challenging situation in terms of data handling, data management, data mining, data processing. Everybody's every moment, every seconds are looking forward that type of analytics. So in that context, we are very happy with the kind support, handholding, and all mentorship from the CDAC Pune. We are fortunate to have some sort of infrastructure, some sort of basic facilities in our engineering institutions and university departments of the state, so that our faculties are able to cope with the situation. But we still would like to go ahead. In the last month only, in Gujarat Science City Ahmedabad, we have opened a world-class robotic gallery with 175 types of robots, and it's a huge presentation gallery with a ground plus 2 floor. So lots of programs, activities in terms of robotics, which will be giving indirectly the promotion and our encouragement and support around our insight to the new age learning goals in terms of artificial intelligence, in terms of machine learning, data mining, data analysis, Internet of Things, and so on. So in that context, we would like to look forward more from our research institutions, our faculties, our students, to explore the opportunity that we have installed 1 or 2 or 3 years before with the CDAC. And we are very thankful to our CDAC and all the faculties, so that they are giving us right kind of support, guidance, handholding, and the roadmap how to go ahead. So with this, so we thought that we should have this program first in a virtual platform, and as the things are coming in a very slower pace to the normal, so very soon we can have a physical workshop, physical training program where we can meet each other physically, and we can also seek the kind support, guidance, and the mentoring of our CDAC faculty more closely and more cordially. So with this word, I once again express our sincere thanks and regards to Sri Ashish Kubelkar sir for his kind consent, kind time for giving some sort of keynote points, keynote address to all these faculties about this workshop importance and our journey roadmap. And I would also like to thank Sri Samrit and all his colleagues who will be our invited guest faculties for all these 4 days training workshop. And I would like to thank all the faculties for their kind interest and support for arranging these programs. And I hope that this 4 days training program would be a warm-up kind of facility, so that with the for the next month, 1 month or 2 months, once the situation is coming to normal, and you people are also busy in your admission process right now, and all the things is going on. Once this things is settled down, so we can have some times and convenient times, dates from the CDAC team, and we can arrange these types of programs in our institutions. So with this word, I once again thank everybody, and I looking forward a very meaningful session, meaningful 4 days training workshop, so that whatever your doubt, whatever your problems, whatever your difficulties are there when you are working in this Param Sabak, HPC and deep learning, and also to seek our kind action plan in the future things, so that how best we can use this machine for the development of so many things in our campus, with our students, with our curriculum, with our societal demand, and a lot of things. So the very best wishes to everybody, and I wish a very meaningful session, meaningful outcome of this 4 days training program. Thank you. Thank you very much.
Thank you very much, sir. Next, I welcome our guest from CDAC, Shri Ashish Kuvelkar, sir, who is the Senior Director, HPC Technologies at CDAC. At CDAC, he has been part of the team involved in development of hardware subsystems for various generations of Param supercomputing systems. Currently, as a convener of NSM expert group on HR development, he is involved in coordinating the activities of the expert group and implementing its mandate by working with various stakeholders from educational institutes and the industry. A few opening remarks from you, sir.
Am I audible, Samrit?
Yes, sir.
Okay. Thank you. It's my pleasure to be part of this inaugural session. And at the outset, I would like to compliment Gujarat Council of Science and Technology that they have a forward-looking vision in terms of what they offer to their the institutes like HPC and robotics, etc. And I guess the inspiration comes from the two great scientists whose pictures I see at the back of Mr. Sahu's room, Dr. Vikram Sarabhai and APJ Abdul Kalam. So they always had that vision, and I guess that's acting as an inspiration to GUJCOST. And HPC is one of the upcoming fields, and I'm so happy that you have been enabling your institutes with Param Shavak, which is a learning platform. And this platform will allow your teachers, researchers to do the basic training in HPC and run smaller codes. However, once they are ready with their need for bigger systems, we have a National Supercomputing Mission in which as of now, about 8 systems have been installed at various locations in the country, and access to them would be available to all the researchers in the country in due course of time. So I would request the participants here to once they are ready with their basic training, once they are ready with the basic knowledge of HPC, especially since they are faculties, they must be having PhD students who would be trying to solve some problem in their respective fields. And with help of HPC, if they are incorporating HPC in their problem that they are trying to solve, then they can always approach NSM for getting access to bigger systems. So let this Param Shavak be a platform to launch yourself into the field of HPC. And I would encourage you to take this forward. And this is a first step, that learning what HPC is. And under NSM, it has been our endeavor to make sure that not only the computer science students and faculties, but more of domain experts like mechanical, civil, then from physics, chemistry, all these people, faculties and practitioners of these domains should take advantage of HPC. And we would like to make sure that we have participation from all these departments in science and technology. We are doing other kind of activities under NSM also, two of which are coming up. I would like to tell here. In the I think from 20th to 23rd September, we have one workshop, a 4-day workshop for those who are working in the field of astronomy and astrophysics. So that is being arranged by IIT Kharagpur. I will send the details through Samrit, the link, the details through Samrit, and he will forward it to you, and you can then send it off to others. So the registration is open till 15th. So in case anybody is in the field of astronomy, astrophysics, they will be able to attend it. Similarly, I will send one more call for paper through Samrit, which is for there is a conference called Hpc, which will be held in hybrid mode in the month of December at Bangalore. And under that, there is an Edu HIPC, which means wherein we are looking at where the participants would be those who teach HPC in colleges. So I think this is a really good platform where all of you are faculties and teaching HPC. So that call for paper and details, both of these I will give it to Samrit after this session is over. I will request Samrit to send it to you, and through you it can be sent to all the other participants. So those who are interested can definitely submit papers or participate in the conference or attend that training program after looking at the schedule of that conference. And one more thing I would like to say is that when we have this, we are now forced to go online and interact within an online mode. So it has its own advantages and disadvantages. My only request to all the participants would be to attend the sessions live. Okay, there is a tendency that, okay, it will be recordings may be available. So you tend to feel that I can always watch it later, but that later never comes. So I would suggest that it would be better that you all watch it live, take some time off. The good thing is I can see is it's arranged only for half a day. So that remaining half a day is free for you to attend to your daily needs. So please make sure that you attend it all 4 days live, ask questions, and if there are any more help that is required through Samrit, we can always provide that. So before I end, I would like to thank GUJCOST for arranging this and all the participants for taking their time off and trying to understand what HPC is. And Samrit and all team members, I would like to thank them also for making it possible to have this workshop arranged. And I'm sure you will have a fruitful session, and let this be a beginning in the sense that it should not be that you just attend the workshop and then forget it. No, please apply it, because HPC is something that once you understand, if you have to keep practicing it and try and explore its new features, if you encounter any problems, we are always there to help you. And as Mr. Sahu said, soon the pandemic will be over and we will be able to have a face-to-face training programs also in Ahmedabad or wherever you tell us. Okay, I wish the workshop good success and hope you all have a fruitful interaction in next 4 days. Thank you.
Thank you very much, sir. So we now start with our technical session. Our first speaker today is Shubham, project engineer and system expert from CDAC. He will be talking on introduction to Linux commands, shell scripting, top tool, screen command. Over to you, Shubham.
Hello everyone. Good morning to all. Am I audible?
Yeah, you're audible, yeah, but your volume is a bit low.
Okay. Is it all right, ma'am?
Yeah.
Okay. I will start sharing the screen now. Is my screen visible?
It's loading.
Okay.
Yeah, visible.
Hello everyone. This is an introduction to Linux commands and Bash shell scripting. In this presentation, we are going to learn how to write basic shell scripts and Linux commands that will allow you to automate tasks that we do. We will discuss its components and we will also performance practical with it. First, we will run and understand some basic Linux commands. The first command is ls. It is used to list all the files that is in a session. Here in this, we have many options available. For listing all the options that this command has, we have another command which is called man. When we run this command with the example of command that we want to see, we just type man and this command. When we run this, it will show us the whole manual of this command. For example, ls, it is used to list the contents in the current directory. It has many options. For example, -a, -b, -c. We can learn all about it from here. First, but for now, we will run some basic options here. For example, ls-a. It is used to in another directory shubham and then so on. This command will show us the present directory that we are in. When we want to go to our previous directory, we type cd dot dot. When we want to go to another directory, for example slash, we just type cd and slash. When I type here pwd, which is present working directory, it will show us on which directory we are in. If we want to go to our home directory, which is /home/shubham, we just type cd. What do you mean by home directory? For example, format, then I will type ls-al. They are the options. They are only optional available. If I type ls, it will show us in the short format. If I type ls-al, it will show us in the long format. It will show us the permission. It will show us the owner name, the group name, the file size, current date and current time, and then the file name. Here, single dot means present directory and two dots means the previous directory. If I type cd space dot, then it will show us the present directory. If I type ls dot dot, that means show us the content of the previous directory, then it will show us this. Next, we have a command called mkdir. It is used to create new directory. For example, in directory temp, I want to create a new directory called temp1 or directory1. When I enter this and when I type ls, it will show us that a directory has been created with directory1. How do we know it's a directory? When we type ls-l, it shows us that before permission, there is the option called D, a character called D. That means it is a directory. For creating a file, we have another command, which is called touch. When I type command touch and then the file name, it will create that file. When I type ls-l, it shows us that the first character here is hyphen, which will show us that this is a file. There are many types of files available in a system, but for now, we will focus only on directory and a file. Next command is Rmdir. What this command does is, it is used to remove the directory that we have created. Here, we have created a directory called dir1 through mkdir command. When we want to remove this directory, we can just type rmdir and then the directory name. When I type ls-l, it shows us that the directory has been removed. What will happen if I have a directory called mkdir and I put some file in it? Let's go to the directory through cd command and create another file called file2. When we go into the previous directory and I'm trying to delete that through rmdir, it shows it shows us that we can't delete that particular directory because the directory is not empty. It's because this particular command only works when this particular directory is empty. So how can we delete this directory and its contents? There is another command called rm. In this, we can delete this particular directory, any file, anything through this command. For example, I want to delete the file called file1. Then I will type rm space file1. And I want to delete this directory. I just have to type rm space dir1. Now, it shows us the error that we cannot delete this because it is a directory. We can use another option of rm, which is -r. It We are telling the Linux terminal that I have to delete this directory and its content recursively. That's what -r means. When I type this, it will delete it. It selects the particular directory and its contents. The next command we have is echo command, but we will learn more about that in upcoming slides. First, we can understand text editors. So, what are text editors? Text editors are used to edit text files, to write codes, to modify files, etc. When we have to write a particular file, we know that through touch we can create any file. But how can we edit it? So there are multiple text editors available in Linux system. For example, VI, VIM, Nano, etc. First we will First we will start by looking at our beginner text editor called VI or VIM. VIM is just a modified VI. When I type this, it shows us that this is the VI improved text editor, its version, it is an open source text editor, and an option to type :help to show us all the all the options that are available and all the things that we can do with this text editor. If we want to edit a file called file, we can just type vim and then the file name. Here, by default, we are not doing anything. So there are multiple options available here. For example, insert, replace, exit, to save file, to not save file, etc. When you look over here, when we type I, it shows us that this text editor is in insert mode. We can type anything here. Hi, my name is Shubham. Hi, my name is Shubham. When I type escape, and then WQ, it will just save the file and exit. So what this option does is W means write, Q means exit, I means insert, etc. When we want to insert a particular option in the text file, we just type escape, and then the option that we want to use. For example, WQ will just write and exit this file. To view the content of this file, I can again type vim and then file1. To exit, I will type escape, colon, and then q. To view the file, to view the content of this file, we have another command. It's called cat. This command will just show us this content in the present terminal. The vim command open another terminal and we can edit the files here. Through cat command, we can just see the content of this file here. If we want to write anything, just type insert, another command. For example, another sentence. For example, we are learning Linux commands. To save this, type escape, colon, W, and then Q. If sometimes it gives us an error that we have to force this, then we can type exclamation mark also. So W, Q, exclamation mark. It will save it forcefully. Okay, so we have learned many of the basic commands here. Next, we will learn about file manipulating commands. For example, chown and chmod. Here, when we see through ls-l, it shows us that this file, the permission of this file are rw-r-r-. This means three things. The first three characters represent, the first character represent that this is a file or a directory. Hyphen means file. The next three represent RWX, which means read permission, write permission, and executable permission. The next three represent for groups. The first three are for owner. The second three are for group. The last three are for other people. So the first RW is for the owner of this file, which is Shubham. The next three are for the group of these people, which is this. And the last three is for other people. For example, other user in this system. When I create this file, I am the owner of this file, and as an owner, I can change the permission of this file. For example, chmod u plus x and then type the file. When I again run this command, it shows us the permission has been changed. We have another method also, which is 755. It means 7 means read, write, execute, read and execute, and read execute, and then the file. How can we calculate this number? The read represents 4 number, write 2, and execute 1. When we add this, it shows us 7. For read and execute, 4 plus 1, 5. For read and execute, 4 plus 1, 5. So we know how we can change the permission of this file. The U represent owner, O represent others, and G represent group. For example, if I want to change the permission of this group to write, I will just type chmod G plus W and then file name. So we have changed the permission of the group command. We have chown next. If we want to change owner of this file to another one, I can type that. Just type Ankur and then this file. Right now it is not permitted because the owner of this is different. It doesn't happen usually, sometimes it happens. Next we have top command. Top command is an admin command utility which will show us the overall usage of the system live. When we run this command, it shows us that all the users which are using this particular system and what are the commands that they are typing. What are the memory usage? What are the CPU usage? Overall memories, overall CPU. What are the how many commands are running? How many commands are in sleeping state? The load average of the system. How many users are currently logged in? To from which time the system is up, etc. It is a very helpful command when you want to see overall usage. So now we have learnt about basic Linux commands. Next, we will move on to bash shell scripting. So starting this presentation, we should learn about shells. A shell provides you with an interface to the Linux system. It gathers input from you and execute program based on that input. When a program finishes executing, it displays the program's output. Shell is an environment in which we run our commands, program, and shell script. It's just an interface. You type a proper command and you get an output. Following are the example of shells. Bash shell, which is the most widely used shell in Linux system. It is used as default login shell in Linux system and in macOS. By default, we use this bash shell. The full form is born again shell. Okay, is that all right? Now, next is we have learned about shells. So what are shell scripts? The bash script is a shell programming language. Generally, we run many types of shell commands from the terminal by typing each command separately that require time and effort. If we need to run the same command and again, then we have to execute all the commands in terminal again. But using a bash script, we can store many shell command statements in a single bash file and execute the bash file anytime by a single command. Many system admin tasks, for example, program installation, disk backup, evaluating logs, can be done by using proper bash script. We can type this command and control statement. We can control those. Here we have run many commands, for example, ls, pwd. If we type this command in a file, save it, and then execute it like a bash script, then we don't have to type this command again and again every day. We just execute the script, and then all the commands that are saved in the script will run. By applying logic, we can format this and understand and run the things that we want. We should learn more about why we should learn shell scripting. What are the advantages? It is very easy to use and learn. Many manual tasks that need to run frequently can be done automatically by writing a bash script. System admin use shell script for routine backup. Debugging in bash is easier than any other programming languages. Bash script written in one Linux operating system can easily execute in another operating system, so it is portable. Moving on to the next slide, we have the basic layout of shell script. In this slide, we will learn about what a shell script can contain. A shell script is a text file that typically begins with a shebang. Then you can write shell commands, which you had learned in previous Linux tutorial. You can control the flow of the script. You can place command. You can redirect data to a file or from a file. We will learn most of this in the upcoming slides. Now, let's start with a basic example. We have a basic script called script1.sh. Here, first we write a shebang that we will understand in a few minutes. Then we have first command, which is echo hello world. Echo is just a command through which we can execute the sentence, or we can write the sentence that we want to print on the screen. For example, hello world. Next, we have pwd command that we have learned before. And we write this in a file called script1.sh. We can execute this by typing bash and then script1.sh, the script name. When we enter this, it shows us that the sentence that we want to print, which is hello world, and the command that we want to execute, which is pwd. It prints the present working directory. Execution of script can be done in two ways. Either we can run the script as a command line argument to bash, or we can grant executable permission to the script so it becomes executable. Right now, we have run the script from first way as a command line argument to bash. This is bash, and this is the parameter that we want to execute first. So bash and then the script name. The next method is we can execute the script through another method, which we have learned before. When I type ls-al, it shows us that the script1.sh and the owner is Shubham. When we see the first three character, which is rw and blank, we know that this particular file has only two permissions, which is read and write command, which is read and write. It does not have execute permission. So for a script, we need executable permission. We know how to change that. We just have to type u chmod, which is changing permission. U means owner, plus, which is used to change the permission, giving permission, plus, and then the permission that we want to give, which is executable, in short X, and then script name, and then enter. When I type ls-al, it shows that we have given executable permission to the script. And when I simply type dot slash, which is present working directory, slash, dot means present directory. When I type dot slash script1.sh, it is executed. When I try this to another script, it shows us that this is a directory, or it throws us an error because it does not have the particular permission which is required, which is executable. Next, we have shebang. Shebang is a line on which hash exclamation is prefixed to the interpreter path. And script 1, we know that we have given a shebang in the first line of the script. Shebang is a line on which hash exclamation is a prefix to the interpreter path, that is /bin/bash. /bin/bash is the interpreter command path for bash. When we run this script through bash, we don't need this. But when we make it executable, we have to let the system know that when we are executing the script, it should call /bin and /bash. This is the line that you have to include every time when you write the script. Now, we know that this is what a terminal looks like. We can execute this command in a single line also by using semicolon. When I type this, it first runs this script and then the another command. it first runs ls, then pwd simultaneously. In shell scripting, we also use comment. Through comment, when we write something in a script, it will not get executed. So let's first the basic command called echo. When we want to write something, when we want to print something on the terminal, we can write echo and then we can write hello, hello world, anything that we want to write, anything that we want to print on the screen. We can use single, we can use double. If you don't want to use any, we can use it also. So it get executed by using double quotes, by single quotes, and by anything. Next we have variable. So what are variables? Variables are essential in every programming languages to store valuing data. There are two types of variable: system variable and then user-made variable. System variables, which are predefined and maintained by Linux operating system, are called system variable. This type of variable are always used by an uppercase letter. Here we have a script called script2.sh in which we are printing three system variables: echo bash, bash version, and home. When we write dollar in front of a variable name, it prints the value of it. So system variables are all in capital letter. These are predefined by the system. So when we execute this script, it shows us that the current bash path is /user bin bash. Bash version is this, and the home directory of present of my user is this. Now we have user defined variables. So to define a variable in the present system, we just have to type the variable name and then its value. To print the variable of this user, you can use echo command and then dollar to print its value and then value of this variable. If you don't use this, it will print only this. If you use dollar, it will print its value. If the variable does not contain anything, it will not give it because it does not contain anything. To unset the value of it, to delete this particular value, you just have to type unset and variable 1. And then again, when I print this value, it will show us this. So type unset and then the value of this. Don't put a dollar, just the variable name. Unset and the variable name. When I again echo this, it will show us that this variable contains nothing. Next, we have exit status. It is a system built-in variable called question mark. When we want to know that the command get executed or not, we can use this. For example, when I type ls, this command got executed. And when I type simply echo dollar question mark to let us know that the previous command got executed, we just type dollar question mark. Is a system defined variable. 0 means the previous command got executed successfully, and then any other value other than 0 means the last command does not get executed successfully. So in the next slide, we have read statements. Read command is used in bash script to take the input from the terminal. Sometimes it happens that we need input from user. So how can we do that? we just had to type the command read and then the variable name. Read variable 2. If I type hi in this, and when I echo $var2, it shows us that this variable contains the value hi. We can do much more with read. Try reading its manual and find full explanation and extra option by using man command name. Next, we have command line arguments. These are also called position argument. For example, when we want to specify the variable and we want to run the script, just take an example here. In this script, we are typing two commands. Echo, first argument is $1. Echo, first second argument is $2. When we want to give variable name, when we want to run the script at the runtime, we just type bash script and the command line argument, just first and second. $1 represent first, $2 represent second. When I type this, it will take the variable in the runtime. Next, we will look at more shell keywords and control flow statement in bash scripting. Flow control in a program is handled by comparison and text statement. Bash also comes with several options to perform tests that are compatible with Unix system level features. We can use if else, and logical operators to perform tests and certain comparison operators to compare data items. In other programming languages, we have also learned about if-else condition or switch statement. In Bash, we also have this. We will see an example of if condition. Here is the simplest example of if condition. First, type if, then the condition name, then keyword, and then the command that we want to execute if that condition becomes true. Here, if I type value of variable, let's give value of variable 1, 5. If I type value of variable 1 is equal to 5, then echo yes. First, we type if, then the variable name, then the condition that we want to execute. We are telling the system that if this variable contains 5 value, then just print this command, echo yes, and then fee. It is very important to end the current sentence in fee to let the system know that we have particular first condition gets true, then execute command 1. If not, then execute command 2. For example, in script folder.sh, we are telling the system that the first command line argument, if the first command line argument value is greater than 0, then just print that that particular number is positive. If it is less than 0, then that particular number is negative. Let's execute the script. Now we have specified that we are giving position line argument. We are providing the value of this particular number when we are running the script. Let's give this value 4. The first argument value is 4. When it will run, it will just tell the system that if 4 is greater than 0, then execute the first statement. If not, then execute later statement. This is how it works. Next, we have loops. Loops are handy when we want to run a series of commands over and over again until a certain condition is reached. In scripting language such as Bash, loops are useful for automating repetitive tasks. There are three basic loop constructs in Bash scripting: for loop, while loop, and until loop. Here we will only cover for loop and while loop. The syntax is very simple. Just type for, initialize the statement, take the condition of it, and then increment it. Here we have a for loop, and when we execute this, it will run this particular number to 0 to 10. Similarly, we have script 6.sh. But in this script, we are telling that the value of I, which is 1, should be less than 3. We are telling the system this is the condition. We are telling that you should run this particular loop until the value of this particular number is less than equal to 3, is less than 3, until that increment it. So it prints the value 1 because 1 is less than 3. Then increment take place 2. 2 is less than 3, yes, print it, increment take place. Then then the value of I becomes 3. Is 3 is less than 3? No. Exit. Next, we have file redirection. File redirection are really important to understand because when to save data or get data in a script to or from a file. Here we have two types of redirection: redirection to a file and redirection from a file. When we want to redirect of an output of a file by filtering the content is one of those essential things that we need to perform. Redirecting or saving a text to a file can be done in two ways. We can just type echo hello world, and then when I type this echo hello world and then give the name of the file, it will just enter this particular file in this temp1. So this text got echoed in temp1.txt file. When we want to append it, we just type this, and when we run this particular file, when we want to see this particular file, we run the cat command. So this will just create a new file, delete the old file, create a new file, echo this to this. Double greater than means it will append the content in it. It will not delete the whole file. It will just append the content at the last line of the particular file. So we have redirecting from to a file. Next, we have redirection from a file. By using redirection, we can read data from a file as follows. Here we have file name John Jan Aman. When we execute this script, what it will do is it will read the content of this file one by one through a while loop, and then it will print my name is $name, which is John Jan Aman. When I execute this script, it will just first read first name, my name is $name, which is John. First line is stored in this variable, and second line and third line. Through this, we know how we can redirect a particular file. We can redirect a particular file in our script. Now we have learned basic Linux commands, what are shell scripts and its advantages, how we can make shell scripts, how we can change the permission of a script to make it executable. What are the basic commands of Linux? For example, echo. And then we have learned about conditional statement, which is if else. Then we have learned about how we can control the flow of the statement through for loop and while loop. Then last, we have learned about how we can redirect it to less than, through command less than and greater than. Now, we have learned about all this in shell scripting. Next, my colleague Om will take this further.
Thank you, Shubham. Our next speaker is Om Jadhav. He is a Senior Technical Officer at CDAC. He is an MTech from IIT Delhi and looks into HPC application experts, supporting benchmarking and HPC application optimizations. And today he will be talking into the introduction to HPC.
Hello, good morning everyone. Am I audible?
Yes.
Okay, thank you. Is my screen visible?
Yeah.
Okay, just wait. So, good morning to everyone. So, now we will have a brief about what the high performance computing means. So, in this particular session, we will be looking at what is exactly the high performance computing means and why exactly it is used. And then we'll touch upon the parallel computing scenarios, then the general structure of the HPC system, and we'll briefly touch about the parallel architectures and programming models, and we'll see the use cases of the HPC system. So, what exactly is the HPC? See, you may have a simple general question. Uh, how it is different from our laptop or PC which you use in your laboratory? Okay, so in general, the HPC is the ability to process the data and perform the complex of calculations at a high speed. So what does it mean? If there is some problem or a code which your general PC or your general computer doesn't solve, okay, it is unable to do those complex and bigger calculations. So what should be the case? So in that scenario, the HPC, or in a layman language, you can talk it as a supercomputers. The computer which is able to perform the greater the complex calculations or bigger calculations. Okay, so how exactly the HPC or supercomputers looks like? So in your general or desktop PC, you may see this is the CPU or the central processing units. So exactly in case of high performance computing or the multi-node systems, the greater supercomputer systems, so this part, okay, have the greater capability to perform the complex or bigger calculations. Okay, and certainly all these nodes are connected by some kind of internet network, and they combinedly do some calculations which are big enough that are not solvable by our regular PCs or systems which are available in our laboratories. Okay, so why exactly we need a high performance computing? So, currently every area or every scientific domains are developing in a drastic way. Okay, so and the backbone of these increment in the technology demand and everything, it is demanding the high computational requirement. Okay, because every scientific development has the computer as a backbone, or the computational ability as the backbone for their research and development activity. So there are different areas which demand different areas from the different scientific and engineering domains which demands the high performance computing for their research and development. Okay, so to list out some of the areas like accurate medical imaging, then realistic computer games and entertainments. Certainly, if the current entertainment industry, Bollywood, Hollywood industry, and the animation industry, they are able to create some the big cinemas or their graphics designs by using these underlying big computational resources. Okay, as well as the climate modeling. So this is one of the area where the HPC is in demand with a great usability. So in order to predict the tsunamis and whether the rainfall and everything, okay, so the backbone of modeling and simulations of the different applications from the domain, it requires the HPC, as well as other domains like a protein folding, the molecular dynamics, for doing the research on the molecular basis levels. It has some complex and bigger calculation applications where the HPC plays the critical role, as well as some other booming areas like artificial intelligence, machine learning, deep learnings. Their backbone is also the HPC. So likewise, there are different and day-to-day basis growing scientific areas where it requires or where it demands the high performance computing. Okay, now just as we move forward, okay, why exactly the parallel computing in case or why you cannot increase the power of only one single course and make it that much powerful that it will perform the required operations, or why we are going for the cluster based approach or parallel computing. Okay, so you may have heard about this the famous uh, law, the Moore's law. What does it tells? In every 80 to 22 months, the size of number of transistors on a chip size gets incremented double approximately. Okay, so but after the few years, means last 15 years of Moore's law has been allowed, means has been obeyed that particular law, but ultimately there will be some physical restrictions on this particular the concept as well, because the size of the transistor cannot be physically less than the size of the atom or the molecules. Okay, so there are some limitations to this as well, so that's why we need something which should be able to cater my requirements of getting requirement of high performance computing. Okay, so scientific and simulation modelings drive the need of greater computing, certainly. So some problems may be big enough, some problems may be big complex, maybe little bit complex, and certainly every problem has their own requirements with respect to the computational efficacy. Okay, so to cater all these requirements, there we have the parallel computing. Okay, so in parallel computing, what we does, we have a underlying resources which are capable to perform some calculations, large number of resources, and we try to divide our workload, which may be the big or which may be the complex. So as a application scientist, we try to divide that workload and assign that workload to the different underlying resources, and we make sure that our work has been completed from those resources with an accuracy. Okay, so to different all these complex and different problems, we have a solution of parallel computing. Okay, now we'll look about what how exactly when we are talking about the HPC or high performance computing or a bigger supercomputers, in general what exactly it has. Okay, so in general it is this, let's say this is the cluster, and it has some login nodes. Okay, the login nodes, all these are the nodes, and all those nodes are connected by some kind of network that is called as a interconnect. And whenever the user comes, it logs into some particular login nodes, and then it sends those whatever the jobs to the these computational nodes, and your work gets done. Okay, so what exactly this node means? The node, okay, it is a single kind of node system where it has a multiple sockets, and every sockets contains the cores. Okay, so this is the general scenario of a HPC, bigger supercomputational HPC system. But in case of, let's say, Param Shavak kind of system, that is the single node kind of system like this one. Okay, and it has multiple sockets, maybe 20 cores of two sockets, and every socket has a every socket has a 20 cores. Okay, so as a Param Shavak system, it has a 40 cores of standalone single node machine. Okay, so that thing you should have in mind. Okay, now exactly what we do in a parallel computing. Okay, generally if there is a big problem, okay, big problem from maybe some different scientific domains, or as per if you are doing some research, and if you find out that okay, my problem required some it is taking some time, more than expected time, and I required to run it on the HPC cluster, maybe on the or Param Shavak system, or whatever the HPC resources which you have. So first of all, you need to find out how you can segregate or divide your problem to different underlying resources, and make sure that it is utilizing the underlying resources by making by doing some chunks of that particular problem. Okay, so divide the problem, assign to that respective processors, and get work done. So this is in general the parallel computing it means. Okay, now what happens in case of the parallel computing? Okay, so in general, in case of your serial program, what happens? You start executing, or you start your problem, then provide some inputs and do some computation. Okay, and get the output. But when you talk about the HP system, you need to work in this particular segments of your problem, where you need to properly divide the work, then communicate whatever the underlying resources you have, just have the information of those resources, and make sure that your workload has been divided in a such way that it is utilizing the underlying resources. It means that you are decomposing your computational workload to the and assigning it to the different resources, and utilizing those for computational computing your problem, and making it sure that okay, you had the accurate work, so expected work has been done from the system. Okay, so this is the general scenario where the parallel and serial systems algorithms works. Okay, now you may have studied in your engineering, or in your curriculum activities, that traditional computer architectures have different different approaches, basic approaches. That is the common architecture, where it has the control memory unit, and control the code unit, and the instruction units, data units and instruction units sit on a single memory. And the another one is the Harvard architecture, where the instruction memory and the data memory are separate one. Okay, but in case of parallel architectures, there are different classifications, or different classifications. The first and famous one is the Flans taxonomy. That's the Flans classification, where it has stated few of the things. Like the first one is the single instruction, single data. Okay, this is the single like a sequential machine, where you have the single stream of instructions and single stream of data, and you are performing like a serial operations. Another one is the single instructions multiple data, where you have a single set of instructions, and you have the large amount of data on that large amount of data, you want to do a same kind of operations, then this approach or this design approach, you can use multiple instructions, single data. Okay, this is the scenario where you have multiple instructions but limited data. In that scenario you can use, but this is not widely used one. And all the current HPC systems or most of the computer systems comes with this approach, that's the multiple instructions, multiple data. Okay, so now what in case of the SIMD in general, like if you have some processing unit over here, okay, so you have the single pool of the input data and single pool of the instruction data, and you are processing something and you are getting the output. Okay, uh, in general the previous the 1980s systems are basically maybe were following this kind of architectures, or maybe the any serial architectures which follows this taxonomy. Then single instructions, multiple data, we have large amount of data, and the single pool of the instructions you are working on, those processing units, through the processing units you are working on those data. This taxonomy is referred as a single instruction, multiple data, like in currently the GPUs or array based processors that follows these kinds of taxonomy. Okay, uh, then the multiple instructions, single data. This is the scenario where you have different instructions and you are working on a limited data. That's the only single data units. This is not means widely used because it has a very little limitations, but has very few use cases like space shuttle flight control computer systems, where you have very less data, and from that data only you need to draw so many different observations. Then in that case or very specific locations it has been utilized. Okay, now the another widely used and most of the current systems, what is the scenario with respect to the multiple instructions, multiple data? The you have the different data pools. Okay, and also concurrently you have the different instructions you can process. So the current all the systems, most of the systems comes with this kind of architectures, where we can at a time we can do multiple things, like multiple calculations of multiple data. Like for example, at the same time you are running one application from the molecular dynamics with respect to its own data, and another from the climate modeling with respect to its own data. So that kind of same scenario comes in this particular category. That's the multiple instructions, multiple data taxonomy scenario. Okay, now till now we have seen about what exactly the HPC, and what are the why exactly we are going for the HPC. Then we just look upon the parallel computing scenarios. Okay, and we have also seen the underlying hardware architectures, the design approaches for different scenarios. Now let's assume that okay, I have the underlying architectures, and with respect to that, how what are the programming models, and on what basis the programming models has been approached. Okay, so if I have some underlying parallel architecture, okay, now among them there are few of the programming models by, and by assuming those underlying architectures, and with respect to different these clusters or different architectures available, we can have different models. Okay, the first one is the memory based, that's the shared memory model, where all the underlying cores or the CPUs, okay, have the same memory loop. Okay, so all these CPUs are situated in a such way that all of them have the access of a single memory unit. Okay, so this particular model is called as a Openmp model, sorry, shared memory model, and in which the widely used different programming models like OpenMP threads can be utilized for programming this such kind of architectures. Okay, like for example, in case of your Param system, it's a single node machine, and a single node where the two sockets are there, so that there is no involvement of the different nodes. Okay, the interconnect and those it doesn't have that. Okay, so that's the one of the example where certainly you can use you can design your program for such kind of systems, the shared memory model, because it doesn't have the interconnect and those kind of things, and situated in a on a single node kind of system. Okay, so now when you go for the multiple node kind of the scenario where it where it comes the scenario of multiple nodes and interconnects and so many computational units, and you need some communication between them. So that's the distributed memory model, and where the programming aspects or programming model it is used, it's called as a message passing interface. Okay, so it has some kind of network. So many nodes are connected to each other by the intermediate network, maybe like InfiniBand or Ethernet or whatever it may be as per the cluster design. Okay, but the in general scenario is that these units or all these units have their own local memory. And for example, this particular CPU wants to access the memory of this particular another CPU, then it has to communicate over the some kind of network. Okay, so it means that this particular CPU doesn't have the direct access to this particular memory. Okay, so such kind of environment where the CPU or the single processing unit doesn't have direct access of the all the segments of the memory. So it's called as a distributed kind of networks, distributed memory model scenario. But in case of this, it was the memory was accessible to all the CPUs. Okay, so that's the difference between this shared memory model and distributed memory model, and the respective programming approaches you can use in both the scenarios. Okay, and another one is the hybrid one. Okay, so all the current supercomputing clusters do comes with this kind of approach design, where this kind of infrastructures available with them. Likewise, there is a single node which is capable of which is having the multiple cores and the shared memory kind of system, and they are connected over the network to the same kind of another resource through the network. That's called as a hybrid model. Okay, and certainly in case of the hybrid one, you can use the Openmp as well as the Mpi programming models and so on. Okay, so this way, certainly this has just some glimpses of the what exactly the HPC system and its HPC system architectures, the HPC cluster level architectures, then the programming models, and certainly these one by one aspects. It has some deep understanding and different itself sessions. So we will cover few of them maybe in next session. We'll talk about this particular MPI. In your previous sessions, the workshops, so we had deeply covered these the concepts of from the OpenMP and as well as the MPI. So some of you may be aware about these concepts and the programming models. Now, so what exactly how parallel computing or the HPC can help you to in your research in what segment? Certainly, it is it will show save the time and money for in different aspects. If you talk about your research and making some out some research journals and everything, it will certainly help you out in many directions. Certainly, it will help you to perform some complex problems and provide the concurrency, and there may be some of the use cases in every aspects nowadays, like research institutes, government and university labs, and certainly the engineering designs, and certainly there are some of the segments where it is widely and it has become the backbone of these industries, starting from the engineering, science engineering, and into that as well different scientific domains as well, including the defense and so on. So now the scene has came where you pick up the domain and you will find somewhere these underlying computational resources or the SPC is playing the role in some way. Okay, so to these are some of the scenarios where the HPC can be utilized and can play the vital role by predicting many natural calamities like a tsunami, earthquakes, and so many things. Okay, and certainly the nuclear weapons and defense related area, it is playing the most important role. So just to brief, so till now we have seen what the HPC and its use cases, and actually this is just a very brief idea and just a glimpse of the HPC introductory session. So more details and little bit more glimpses of respective sessions will be provided in maybe upcoming sessions. So till the moment, do you have any doubt or question? So maybe 1 or 2 minutes we are open for this question answer sessions. Then we'll move to the next session. So is there any question?
Participants, you may please post your questions on chat message, as well as you can unmute yourself and ask the questions directly to the speaker. Thank you.
For those on YouTube, you may also post your questions there. We will take it up here in this session.
Yes, certainly.
Okay. There's a question
Okay.
which is better, MPI and OpenMP.
Uh, See, to answer the question, this particular question, just we need to understand in which scenario basically these programming models are used. Okay, so certainly we cannot say that this is the one better and that is one not better, because both are used to make the large number of HPC resources efficiently to solve our problems. Okay, so the OpenMP is used in the case of the single node, or in a layman language, in a single node kind of environment, that's the shared memory model environment, like in case of the param systems. Okay, where it has the single node and it is a shared memory kind of system. Okay, and now if you have large number of nodes, okay, and if you want to make use of those distributed nodes connected by some kind of network, then certainly you need some kind of mechanism where you will be able to communicate between those nodes. Okay, so in that scenario, that's the distributed memory model scenario. In that scenario, you need to use the MPI. Okay, so if you have a shared memory kind of system, then certainly the OpenMP will play the important role, and you can go for it. Okay, and in case of the distributed memory kind of system, you can go for MPI. But now the current all the if you want to test and see the performance and those kind of things on a single node, okay, so MPI is also supported for a single node as well, but you can explore it on the single node or this shared memory model as well. Okay. So I think MPI generates some delay. Yeah, certainly, because see, for understanding these things, just we need to understand the two concepts, like what is exactly the shared memory model and distributed memory model. On the shared memory model, the communication happens through the bus, which are available on that the server board itself. Okay, so through the communication between the bus, it's very quick. And when in case of the MPI, yeah, the communication involves the interconnect, some network like a InfiniBand and that kind of things. Then certainly in that case, the communication overhead is there. So that's why the MPI generates some delay for the communication overhead. Okay, so just you need to understand the scenario where these particular programming models are used, and it's a simple way to understand the things. I hope you get it. Yeah, thank you. So, is there any other question? Does multi-threading approach improves the performance in parallel computing? Certainly, for example, it also depends. In some cases, multi-threading will help, but in some cases it may not help, because it also depends on how frequently you are trying to access the underlying resources, as well as the cache pay effect, and those kind of things, scenarios will come in picture. But certainly it depends on the how your algorithm has been designed, and those aspects. Okay, but in general, what we have observed, or if you have, let's say, 40 cores, underline 40 cores, and you should be uh, able to design a program or a problem which efficiently use those particular underlying cores. Okay, and if you try to multiple spawning large number of threads on a single course, if your problem is suitable or supporting that kind of means environment, and it is giving the better results, in that scenario, means like providing large number of threads to a single core may help. But it depends on your code and algorithms, how it is distributing the workload to the cores, and those kind of scenarios. Okay. Yes, thank you. So, is there any question other than this? So, if not, then we can move for the next session. So,
Yeah, sure.
yes.
Thank you so much. Our next speaker is Ranjit, who is a technical associate at CDEC. He is a B from RTMNU Nagpur with a PG diploma in advanced computing from CDEC IACST. He is an HPC application expert, and he also he'll be talking on MPI programming with C or Python. Yeah.
Hello, am I
Yes.
audible to all? Yeah,
Yes. Yes.
yeah. Good afternoon to all. So, in this session, we are going through for the introduction of parallel programming with the MPI. So, we will go through the concept of MPI, how MPI work, what are the supported languages for MPI, how we can implement MPI in order to get resolve our problems with the help of supercomputers, or the system which is provided by us in a form of permission, or any system you are using. So, what is parallel computing? In previous session, you gone through the main concepts of parallel computing. So, for the overview, I'm just explaining little bit about parallel computing. So, as we all know, we have a single computer. We generated lots of technologies like we can implement on single chip. We can implement quad core, octa core processors, but for the utilization of more computational requirement, like for weather forecasting or for genome or drug discovery kind of thing, you have to go for the larger systems which have more number of processor in terms of 100,000 and million of processors are available there in order to give output in a minimum time with efficient and optimistic way. So using many computer linked together by communication network to efficient perform a computation that would not be possible on single computer. This is the main drawback of single processor, or we can say normal system. So a single computer have a stagnant in a performance, means it's lag performance if you go for a higher computation, and also if you are working on huge amount of data, it will lag in a time also, and also it give a very cheap performance, you can say that, which is not required by you. So parallelization cannot be handled for the user by the compiler. Here we are saying that it's all depend on user, how it's he deploying his program on such kind of system to utilize underlying system. So various approaches of the parallelization are there since 90s, and we will go through it and we will see how it's work. So parallel programming models are there. There is shared memory model which is used for mostly for multi-threading. If you're going for the Openmp programming kind of thing, you can go for means this kind of model is implemented. Kindly, if we talk about Openmp, it work on this memory model because all processes are use same memory area in order to establish communication between them. So for the small computation or less amount of data, where less data is required for the computation, we will go for the shared memory model like Openmp. And if we have huge amount of data and we have a large system which has a number of node, and in order to utilize each node, we must go for the MPI, which is an message passing interface, which is used to establish communication between the processes in order to give a proper output in a minimum time. So as we can see that in distributed memory model, here all nodes are separated, and each node have its own CPU power, its own cache memory and main memory. So if we are going for the large amount of data, and our computation is also means quite complex, at that time we will deploy our problem on distributed memory model, and by using MPI we will perform the operation on it, computation on it, and then we will get a proper output in minimum time in most efficient way. Here we can say that, as there in previous session there was a question, is there lag is there in MPI? Yeah, lag is there in MPI, but if you are going for complex problem and your problem required a large amount of data, at that time this lag is nothing. If uh, you want a efficient output as compared to OpenMP. It's also depend on your implementation, which programming model will give you a proper output. So parallelization technique, here message passing is done in distributed computation. Means if we are talking about MPI, it mostly done on a distributed memory model, and so uh, there are number of computer connected with the interconnects, which is communicate between each other with the help of interconnect. So assume that each computer has its own memory, not shared. So here we can say that if we are going for the hybrid model like OpenMP plus MPI kind of thing, where shared memory and distributed memory are hybridly constructed. So at that time we can implement both kind of scenario like OpenMP MPI. So as we all know, in shared memory, the processes communication will be done on the basis of the shared memory area. Here in MPI, the message passing is there between the processes in order to utilize underlying system. So MPI, the full form of MPI is a message passing interface. MPI is not a programming language. In some people there are some misunderstanding like if we are going for MPI, do we are dealing with new languages. So I want to clear this misunderstanding that MPI is not a programming language. It is a programming model. You can use any supported languages by MPI in order to utilize or to take a benefit of MPI. There are Fortran is there, C++ is there. Also currently Python is also for is there. Currently we can use MPI for Python for the Python implementation. Is mostly like object oriented like C++ model. It is closely related to it. So MPI provide function macros libraries that we can write in any supported language, as I already mentioned. And if we are going for any kind of uh, data or computation which required such kind of implementation, we can simply implement the MPI program in order to get a solution of our problem. So basically, most MPI program are based on SPMD model, which is a single program, multiple data. Here we are talking about the specific computation, like if we are going for the weather forecasting or bioinformatics applications implementation. Here the data with the data which is available is huge, and we perform computation on it. A single computation has been done in a single time, and then after we will combine the output of all processes, and there will be a proper output in a final we will get. So what are the preliminaries before going for the MPI? The basic concept of MPI is the communication between the processes. How we can establish the communication between processes, how we can implement routine MPI routines and function in order to get final output. So a process is an instance of program and can be created or destroyed. As we all know, under program under execution is known as process. And if we want to communicate between process to process, we will implement the MPI. So MPI uses statically allocated group of process. There is a number is set at the beginning of program execution, no additional process created. So if we are talking about multi-threaded application, there is a concept of multi-threading. The single process generate a multiple thread, and the computation will be done by the those thread. The same will happen in GPUs. There so are the concept of multi-threading also. So this computation is different, but currently we are talking about multi-processing. So if multiple processes are working, there should be a specific number of processes. So each process assign a unique number of rank, which is from 0 to process minus 1. If we are giving MPI process number like 4, so the total number process, the number of assigning the process is like 0 to 3. So we are subtracting minus 1 from the total number of processes. This is the uh, processing. Each process is nothing but a processor core which is working on your computation and then providing the final output. Running MPI program with one processor core is fine for testing. Like Om sir is already stated that if we are going for multi-threading and we have only single node, we will utilize that processor by use implementation of Openmp. But if there are lots of node available and you want to utilize that, then it is always advisable to go for MPI. So how exchange data between happen between the processes? So processors do not share memory in a distributed memory model. They has distinct memory space, and the communication data between the process explicit function call must be made in a program. So for the implementation of the communication establishment, you have to use some function call to establish the communication between the processes. In the most basic exchange, the process which has the data needed by the another process call a send function. Here we are the sending data which is required by the another process, and this data is available to some another other process. This data will transfer from source to destination with the help of the MPI functions or MPI routines. And we will see these routines and function in further presentation. So, and process which receive the data call a receive function. So, if a sender is sending a data, there must be a receiver which is there for the receiving that data. So, both send and receive must be executed for the completion of communication. So we can say that after both send and receive executed, we can say that the communication has been successful. So the basic MPI program structure, as we can see on a screen here, we are first if we are going for Python, we will include we will import the Python 4 libraries. And if we are going for the C language, we include the header files which is required for the successful MPI program execution. After that, we declare our variables which is required for by our program. The basic initialization done in a C language by MPI init. It is an initialization of MPI program. After that initialization, we will write our program. So there are some dependency in our program which will not be parallelized. If we are going for any program which have some dependencies, and the portion of that program will not be parallelized, because if it has a dependency of some different data, so that portion has to be a serial. But if some portion of your code there are chances of parallelization, this kind of code we will implement with the MPI, and that MPI function and routine utilize the underlying resources with a parallel model, and then after the compilation the execution will done, and we will get a final output. So this parallel portion of our code will implement the MPI, and then after if further computation will done, and after that we will get final output. So if we think about 100 lines of code or thousands of lines of code, there must be a portion of code like a 400 or 500 lines of code. There must be chances that it will be parallelized code. It's all depend on your problem, that how much data dependency is there. Depending on it, you can utilize your you can implement MPI in your code, and you will get the benefit of it. So MPI for Python. This is a message passing interface standardized as package. Means MPI supported package which is provided by the Python, and it is an portable function. So for MPI for Python provide MPI binding for the Python programming language. So this package build on a MPI specification and provide an object-oriented interface which is closely follow MPI to C++ bindings. So here we can see that here we are standardize the MPI with the Python language binding, and it will help us to get more benefit of Python in order to get resolve our problems. So for example, parallel MPI program structure with Python is like first we will import the MPI 4.5 module, then we initialize the MPI and do our computation using MPI communication between processes. There are two kind of communications are there, like point-to-point communication is there and collective communication is there. These are the advanced concept of MPI. We will cover this all concept in further slides. So after the completion of computation, we shut down the MPI by using finalize method in C, and after the finalization all the resources which is acquired by the MPI will release, and your system is ready for the another execution. So for MPI for Python, you have to create an MPI communicator object which is used for the communication between the processes, two different processes. So for this you have to import MPI 4.py from this module, and then after you can declare the variable like com. Here we are, this is the syntax that MPI com underscore world is defining as a communicator object. So it's a method will be used to carry out the communication between the process. Same here is a com.send, which is used for the sending the data from one process to another process. This is the basic syntax of com.send. Here we are providing the object containing the data to be sent. Then we are providing the destination, that is the rank of process to which we are sending the data. And there is a tag, which is a number which can be used to distinguish among the message. If we are sending multiple data to the same rank of process, in order to distinguish between the message, we providing as unique number which is here we are saying the tag. This method may complete before the data is actually transferred. If the object being sent is small enough to fit in a buffer used by MPI for the communication. So com.send is an blocking call. If we are sending the data to a specific processes, it will stop push sending another data until this that data will receive by that process, means the destination process. After the completion of this cycle, the another data will be sent to the uh, processor which required that data. For receiving that data which is sent by com.send, there is a function named com.receive. This method is also included in MPI for pi.mpi.intercom instance. This method belong to this class, like com.receive. Here we are providing the argument like buffer, which is optional for the containing the data to be received. It is an buffer provided for saving the data temporarily. And then for the source, we providing the rank of process from which it is receiving the message. there is a unique number called tag, which can be used to distinguish between the message, if we are sending number of messages to the same process or same number of data to the same process. And there is also a status which provide the information that data will means received or not, and it will give a rank of source and the specific error if data is not uh, received by the receiver. And there is also a tag which we can use in order to know that which tag number data is not received by the receiver. And if this operation is successful, it will provide the status as a success, so function return the data received. This method is not complete until the corresponding com.send has been executed on the source process and the data has successfully transferred. This com.receive is also a blocking call in MPI, which will work only when com.send has successfully executed and data transferred successfully from com.send. And after the whole completion of this cycle, we can say that the data is received by the receiver. There is another method like com.getRank. This return the rank of the process in a communicator. So rank is nothing but a number assigned by the system to the processor, and if it is numbered by 0, as I already stated, the number will start from 0, and if we are going for the 4 number of processes, we can say that the process number like 0, 1, 2 and 3, these are the 4 process rank which is assigned by the system. So if we there is another method called com.getSize, which will give information about total number of processor in a specific communicator. So it return the number of process in a communicator. So if you talk about basic MPI routine, I already stated that MPI com.getRank. It is an Python method, and here MPI underscore com underscore size it is a C implementation. Here we can see that in this diagram that here P0, P1, P2, P3, these are the 4 processes. And if we talk about the complete size of this communicator size, we can see here 0, 1, 2, 3, 4 processes are there, and rank is not assigned to it. If we talk about MPI com.rank underscore rank, we can see that here after the communicator size is allocated, the rank will be assigned to each process. So after the ranking assignment, here we can see that P0 got a P0, P1, P2, P3 processes are assigned to 0, 1, 2, 3. These are nothing but a rank of these process. And if you want to get this rank and size of communicator, you can go for the methods. And there is a question, I think, how to get the rank of process to which we want to send data. Actually, if we are implementation rank is not known by the user, it is assigned by the system. So if there is a data dependency, so that process is automatically okay. So data is automatically transferred to the as per the user. So if you are mention the rank, random rank, So it will transfer that data to by rank variable. So it is all depend on the user how he is assigning the rank. It is actually it is provided by system, and you only mentioning the direction of the communication. So if you want to transfer the data, you only mention a random number, and the communication will establish between them. So uh, I hope it is clear to you.
तीन मिळवण्यासाठी रँक व्हेरिएबल जे रँक असतो ना तो रँकच आपल्याला हे करतो.
As I already stated, there is a rank method which will provide you a rank of a specific process, and depending on that rank, you can establish the communication between the process. So for getting the rank, you must go for the this com.getRank. By calling this method, you will get the rank, and after the getting the rank, you will perform the operation of communication depending on your application. I hope it is clear. Okay, there is a message. Okay, thanks. So we can move forward. So this is a first program in Python using MPI 4.5. So for using it, we first import the module from MPI 4.5, import MPI. Then after we are declaring a variable com, which is in which we are calling mpi.com world, and then here we are getting a rank by calling the com.getRank. As I already stated this method, in order to get a rank, you have to use this method to get a number of rank. Here my rank is the variable name, and then after we are getting the process number, total number of processes in a communicator. So it will provide a total number of processes in a communicator. Here the variable name is p for that. Here we are using uh, statement, if statement. If my rank is not equals to 0, we are sending a message hello from the string variable is used my rank. So as we already see here, my rank is getting the rank of uh, all processes. So here we are sending hello from 0 to 0 by all the processes available in a communicator. So I am sending the data from communicator.send and message to the destination 0. So this else statement is there. Here we are uh, going for the for loop on the basis of process ID in a range from 1 to p. Here p is a total number of processes available in a communicator. So we are sending the data from the other processes rather than 0, and this message will delivered by all processes to the 0. So on Param Shavak, in this session, it is not covered, but we will provide some session in further session workshop. We will talk on it, and as time permission, give a permission, we will provide that also. Installation process of MPI 4.5.
Hello. After the sessions,
After the sessions, we may provide you a guide how to install the MPI with respect to the Python. Certainly, yes. Thank you.
So, I summarize this MPI essential to write a simple MPI program, parallel program. You only need to import the module. Then after, you can go for this method for the implementation of the MPI in your program. So, for getting rank, you can call the dot get rank dot get size. You provide the communicator number of process. Com dot send is a blocking call. We are sending the message to the specific rank of process in order to establish communication. Then finally we are call MPI finalize, which will release all the resources which is acquired by your program. So in example output, we are running our program by mentioning this MPI run program, MPI run command. Here we are mentioning the number of processes. So here we mention a 4. So the number of processes in communicator are 4. So for Python program is there greetings.py. So process 0 receive a message from process 1. So we are sending the message from process 1 to process 0, and it's saying hello from 1. So this is the output of this program. Uh, this is a basic program for MPI using Python. So if we talk about advanced concept like point-to-point communication, MPI point-to-point communication operation is performed between two different processes. So if we are performing some kind of task and there is a need of the communication, and this task is executing on a different node and communication establishment required there, so we can go for point-to-point communication. This point-to-point communication is basically used for the data dependency problem, like if the specific data is required by a specific processor and that data is available to the another process, so the communication will be done between this processor. What is the difference of rank and the PID in a MPI? Why we are not using PID for the communication? Actually, rank and PID are the both same things, and here we are getting rank is nothing but a process ID only. Process ID is also known as rank.
Yes. In case of MPI, process ID is called as its rank. And to clarify on this particular doubt, uh, whenever we specify some number of processes like MPI run hyphen NP4 and then executable while running the program, then what happens? The compiler spawns 4 number of processes. Okay, and when it spawns, the means the compiler randomly assigns some ranks to each processes. Okay, now as a user, if you want to see which rank has been assigned to which process, so we call some of the routines like mpi com rank. Okay, so when we call that particular rank mpi com rank, then we get to know that okay, this particular process has been assigned this particular rank. And by using that particular rank, we can do some communication with respect to sending to some message or receiving to some data from that particular like a process. Okay, and certainly in case of the MPI, the process ID is itself called as its rank. Okay, so I hope you got it. Okay. We can continue. Maybe we'll wait for the response from
So point-to-point communication is established between two different processes, and there are two types of this point-to-point communication: blocking method and non-blocking method. Here we are going through the C syntax. Here MPI underscore send is an basic routine which is used for the blocking call for the send operation. So the operation is same like a com.send, and this routine return only after the application buffer in a sending task is free for reuse. As I already stated, as we are performing a blocking call here, so after the completion of its execution, the next data will be transferred. So for this syntax, you can see that the point-to-point communication blocking for blocking send, uh, here we are providing mpi underscore send syntax, in which there are argument like message buffer, which is an pointer of the buffer, and here we are also providing a message size in terms of data, which is if we are going for the integer data transfer, double data transfer, or a float data transfer, we have to mention its data type, and after that we are mentioned the destination address, which is a rank of the destination process, and we are providing the unique number for the tag, and we are using mpi communicator here for the total number of process. So the here address of message buffer is provided, message size is also there, which is in total number of byte, which depending on your data type you are transferring, and the destination rank address, and for the unique identification of your message, tag is also provided there. It is an MPI send, in which these orange color argument are the state argument which are telling us the information about the message, means what kind of message we are transferring, and these blue argument to tell us where and how to send a message. So these orange color argument are the basic information of message to, means it provide detail about what kind of data type you are transferred, the size of that your data, and the destination address, or what kind of message you are transferring. Uh, and to which process, and these blue argument tell us where and how to send a message, like the destination address, the unique tag number, and the communicator. So point to point communication here, MPI receive method is there, in which receiving a message and block until the requested data is available in application buffer in the receiving task. It is then also a blocking call. So after the whole completion of whole process, it will give a successful message status after the receiving the data. 1 minute. Sorry for the interruption. There is a charging issue with my laptop. So for the successful transmission of message, these both function will execute, and then after we can say that the communication has been established successfully. Here is a comparison between the MPI send and MPI receive blocking call. Receive communicator and send communicator, and unique tags are provided for receiving tag and send tag, and also destination process rank and source process rank are mentioned in this argument. If a process is there, if we want to communicate a particular process, how it can, it is done by providing a rank, by getting it ranked by com.rank, and you will get that specific rank of process, and by using that rank you can communicate between those processes.
Uh, to answer the question asked by Vallabh Patel, in addition to what Ranjit has specified, is five process is there. If we want to communicate a particular process, how it can be done. See, while writing the program, uh, you need to mention the process. Okay, like for example, if you want to communicate one particular process while writing its program itself, you should mention that, okay, I want to send this particular message to, let's say, rank process number 3. So likewise, you should by using that particular rank variable, you should specify rank equal to like prime number of number, like a rank 3 process. Then certainly it will, that means automatically it will try to communicate it over here. Like for example, uh, Ranjit, can you go back to uh, last slide? Uh, yeah, okay. So you can, like destination process, normally you need to set the previous one. Okay. See here, int destination. Like for example, in MPI sent, there is the tag number of, like parameter 4. That's the MPI int destination. So here you can mention over that. Okay, I want to communicate for the process number, like a rank which has been having the rank number process is equal to, let's say, 4 or maybe 3. Here you can specify over there, and while writing the logical looping statement, or over there you can specify that particular rank over here. I hope you get it. Or maybe if you have any, if you require more clarification on that, you can certainly provide us mail. We will clarify it more. Okay. So rank is equivalent. So is rank equivalent to priority? No. See, first of all, try to understand the basic things. Okay, what is the rank and what is means communication size and those kind of things. Okay, see, what is, first of all, I will try to explain what exactly the rank means. In case when you try to run a program on, let's say, 10 number of processes at the runtime, mpi run -np, let's say 10, and you are specified your binary where you want to run that particular binary on 10 number of processes. At the time of that run, compiler will spawn 10 number of processes. Okay, and when it will spawn the 10 number of processes, at that time it will assign random identification numbers, which is called as a rank, to each process. Okay, so that when in future, maybe in while running in between, so that particular process itself should know that, okay, which rank has been assigned to me. For that particular purpose, you need to call the mpi com rank, that mpi routine. Okay, once you call that particular routine, so every process will get to know that what the rank has been assigned by the compiler to that particular process. Okay, and by using that particular process, that particular identification to each students, let's say from starting 0 to 9. So from his side, he has randomly assigned those numbers, like from 0 to 9 to his students. Then he will pass those numbers to each and every students. Then after they will now when they will get those identification, so by the right, like getting this mpi com rank, that particular routine. Okay, when this particular routine will be called, then that particular process will get to know that, okay, this particular rank has been assigned to me. Like in case of the professor, when he will provide some details, that details, okay, I have specified that particular rank 0 to you, then only that student will get to know. And once every student or every process knows that, okay, this particular rank has been assigned to me, then he will be sure that if I want, this is my rank, okay, and let's say for example in a program, the program has been written in a such way that okay, this particular portion of the program has to be performed by me, okay, then he will perform that part of the program only. If another part of program which has been specified that okay, this particular part of the program has to be done by this particular rank, he will not do that, okay. And that happens in the in case of the mpi, and that comes under that how you are sharing the workload among the different processes, and those kind of things happens over there. Now let's say for example process p0 wants to send some data to process 3, okay. In that case what he will do, he don't need to worry about okay how the message is communicating, how it is happening, and the data is transferring and everything. He just need to say, specify in his destination message, okay, in the mpi routine message, okay, parameter, okay, I want to send this particular data to process number, maybe that which has been assigned by the rank, like for example process number 3, okay. So he will in the destination parameter he will provide that number, okay, and the mpi underline mpi communication will take care of that, and he will try to communicate with him, okay, in the communication word. And how every process will be getting to know that how many number of processes or how many number of members are there to which I should communicate, that is means that information can be get by the MPI com world, that particular MPI routine. Actually, these things we had covered means in detail in the last sessions of MPI, maybe in last workshops. So that's why we were assuming that these small things may be clear to you, but no issue. Other than that, if you have any kind of doubt or clarification, we are there to solve those concepts. So I hope you get it. Yes, Vallabh Patel ji has asked once again, okay, but the earlier the doc rank is automatic. So I think Vallabh ji, you got it. So another question is there: is there a timeout mechanism for MPI calls? See, in case of the MPI, there are two things. Okay, like basically two things. One is the point-to-point communication and the collective communication. Okay, like in a point-to-point communication, the communication happens between the only two processes, okay, like a directly point to point. And in case of the collective communication, the communication at a time is happening with more than two processes, okay. Now in the point to point communication also there are two things. One is the blocking point to point communication and the non-blocking point to point communication. In case of the blocking point to point communication, what happens, and in case of the non-blocking point to point communication, what happens, for that you need to understand little more deep concept. Like for example, I will try to explain it, okay. So in case of the blocking point to point communication, what happens, there are two parameters. Like for example, you want to send some message from process 0 to process 1, okay. So in order to make this communication possible, what things are involved? First, let's say for example, it is the process P0, process P1, and there is an interconnect in between them, okay. So and let's say assume that in the process P0 there is some its own like a register memory, where whenever it completes some its processing, it stores that message to that particular register memory. After that, it will try to monitor the network. If network is busy or some kind of things, he need to monitor. After, like for example, there is a called as a network buffer. Once he will complete his calculations, okay, like for example what it has been specified, okay, let's for example here only, okay, let's say in the previous case, see this, let's say this is the scenario. Okay, so process P0 and process P1. Okay, this is the buffer, like a register buffer from where once this particular process will complete its operation, it will try to put that data into here. Okay, and once it will be it has done, it will try to transfer it to network buffer, and once the network is free, it will try to send to the destination process. Okay, now what happens in case of the blocking point to point communication, where the process will come here, and it will transfer to the data will transfer to the network buffer, and it will wait till this particular data has been transferred over the network. Okay, till the moment he will not start the next operation. Okay, in case of the blocking point to point communication, so what is happening over there, it is blocking himself till the that particular data has been transferred from network buffer. Okay, like this, for example, it has blocked himself for doing so next operations till the net data has been transferred, like transferred to the network. And in case of the blocking non-blocking point to point communication, what happens, this particular processor will not wait till the, like for example, is there a slide with respect to that, Ranjit? I think it okay, non-blocking, blocking, non-blocking point to point. Yeah, okay, this is the slide. Okay, so it will not wait till the moment this particular data has been transferred to the network or not. Once it will it transfers that message to the, let's say, network buffer, it will start another operation. So there may be few of the another cases where, for example, the network is so busy that this process may complete its operation. Okay, and come with some data. Okay, still this particular data may be in the buffer itself. So in that case, in case of the non-blocking point to point communication, it should not overwrite that particular data and those kind of things. Some more detailing or deeper kind of concepts are like their wait or check kind of like routines are there, test routines, wait routines, or Mpi routines are there, like this. Yes, this the Mpi test routines where we need to specify where we need to check whether the data is present or over there or not. So this blocking point to point communication and non-blocking point to point communication, there is syntax difference is also there. Like for example, in case of the Mpi send, Mpi send, so Mpi send is just nothing but the blocking point to point communication. When you specify the Mpi send, and it's another one parameter, that the request parameter is extra over there in case of the non-blocking point to point communication. So this is the scenario where yeah, in Mpi works likes. I hope you got it. Another question, yes, clear idea. Programmer is the master of rank management. Yes, certainly. See, in case of the Mpi, always remember that in case of that, there is no master process. Okay, as a programmer, you need to specify everything, the logic, distribution, workload distribution, and how it is communicating and everything. So many people or many research scholars thinks that okay, if I have a supercomputer like a Param shock system with me, and any program I will just try to run on it, it should, my program, if that is running taking 10 minutes on my laptop, it should directly take some lesser amount of time if when I run to that particular on the supercomputers. But always remember that these workload distributions and the managing and making it communication available, and that particular scenario has to be done by the programmer itself. Okay, just only what you have only the underlying resources which are capable to run your parallel program. Okay, the logical and running and utilization of that underlying resources has to be done by the programmer itself. Like for example, sharing the workload, like say if you want any user like that professor, let's say I had taken the example of professor and students. If he wants to do some calculation from 1 to 100 number of processes, okay, 100 number of numbers, sorry, okay, 100 number of numbers, he wants to do some calculation, then the professor itself has to assign some that workload. Like, let's say for example, a student one should do some work from that process 0 to process 9. The student 2 should do some that particular calculation from 10 to 19. So this kind of workload distribution has to be done by the master or the who is writing the program itself. That's called as a workload distribution thing. Okay. Yes, we will certainly share the slides with you. Certainly, after completion of the training programs, everything will be provided to you. Certainly. So, along with that, is there any doubt or question still? Okay. Okay, fine. Yes, Ranjit, you may take another maybe 5 to 10 minutes. I think yes, we are done from our side. Other than that, is there any doubt or any question? I hope you understood the things. So, two things. First of all, how to install the MPI for the Python. We will provide you the guide. Maybe through the mail we will communicate it that, or maybe by when we will send the documents, we will provide you the document how to install the MPI. Other than that, if you face any kind of challenges for setting up that, we are always ready to help you in every aspects to solve your queries or problems. We will do that, certainly, no doubt, with respect to installation part of the MPI and the MPI, specifically the Python MPI and directly MPI, like for example, certainly on your PermShock system itself, the MPI is available by default, so you can, till that moment you can explore it, the C part of the MPI. So other than that, do you have any doubt? Any question? Maybe we for next 2 to 3 minutes we will be open for question answer sessions. So any doubt with respect to basic concepts of HPC as well as the MPI? You can also unmute yourself and ask the questions if you have.
Hello, sir. Will you arrange Openmp session? Or is there any session about?
Uh, Please, can you repeat the question?
Sir, is there any Openmp session or not?
Open SEC session.
Openmp.
Open MP session.
Memory pool.
Open. Okay, sir. In this particular means workshop, we had not included that part because we had already covered that in the previous sessions. But if you require any kind of help or guide, we will with our means the documents we will provide you the PPT with respect to that, certainly, or maybe somebody sir can comment on it, sir. Okay.
Okay, sir. Send the PPT, no problem.
Yeah. Oh, okay. 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 Fine. Yes. Other than that, is there any question or clarification with respect to any concept? So if no doubt, then I think we are over for today's session. So Dr.
Yeah.
Payal.
Yes. So I think it was really nice, and I think our participants must have uh, benefited from these all three sessions. So we look forward to the introduction to GPU computing, application optimization strategies, installation of HPC application, demonstration and use of PBS scheduler tomorrow. So meantime, if the participants, if you have any comments or you may write to us, or you can post it in our WhatsApp group, or maybe by during tomorrow's session, you can post your queries. So thank you all for attending today's session. And I request participants that please do not leave in between. Attend the complete sessions. So that will be beneficial to you as well as your institute. Okay, so thank you so much. Thank you all the speakers for today. And we can close the session today.
Thank you very much.
Yeah.